a world population rapidly approaching 7 billion, the stresses that mankind is putting on itself and its environment in the struggle for resources are continuing to grow. Water is an excellent example of this. It is necessary for survival and also used in every other aspect of our daily lives. This is especially evident in India, the world's largest democracy with over 1 billion people. To further study these issues, 11 members of our class traveled there to the state of Gujarat and the city of Dahod to work with Sadguru. Founded in 1974, NGO Sadguru Water and Development Foundation is a non-governmental organization that works to improve water quantity in rural Gujarat using several methods. They've built numerous check dams, which are placed in the riverbeds of seasonal rivers to keep the runoff from the monsoon for irrigation and recharging of the water table. They also build lift irrigation schemes, which pump water to the high point and then utilize gravity to distribute water to the fields below. The ownership and responsibility for upkeep of these systems is given to water councils that Sadguru helps establish and educate. Sadguru also has expanded into other areas, such as floriculture, horticulture, and forestry promotion. Through these efforts, Sadguru has sparked a radical change from arid wastelands to lush farmland. During our time at Sadguru, groups of students traveled to local communities, Ranipur, Sikarda, and Rozam. While here, we conducted health and household assessment surveys. We met with pawn-shops of the community and invited these leaders to come to Sadguru for a final presentation. We looked at local sources of drinking water and took samples. At Sadguru, we analyzed these samples using various tests to determine levels of different contaminants. Models and displays were constructed of various sustainable and appropriate technologies for improving water quality, which would be shown at our final presentation. On our last full day at Sadguru, we gave a final presentation of our findings to members of the NGO and the communities that we had worked with. Water from the communities was determined to be suitable for drinking use. However, there was room for improvement, specifically in removing disease-causing pathogens, as well as concerns about lowering the concentration of fluoride. We were pleased to see that Ranipur and Sikarda already had centralized infrastructure for water distribution through taps. And even in Rozam, there were many hand pumps throughout the community that provided potable water. Based on our findings in the community, we suggested several appropriate technologies to improve water quality. Because none of these technologies are foolproof, the best system would use several of the following technologies in a multi-step process. The first technology is based on prevention being key to improving water quality. A pit latrine works to contain human fecal matter, which protects runoff water from contamination. When fecal matter is uncontained, water runoff from rain becomes contaminated and also contaminates the bodies of water it flows into. Lowering the initial contamination increases the effectiveness of all the remaining technologies. The next technology utilizes nature to our advantage. Moringa oleifera is a tree that occurs naturally in India. When its seeds are ground up and placed in turbid water, its positive charge cancels out the negative charge of the contaminants, facilitating the growth of larger particles which settle out of solution and can easily be filtered. The third technology functions as a physical and biological barrier to contaminants. A slow sand filter is composed of layers of fine sand, coarse sand, and gravel. Any particles larger than the fine sand will be unable to pass through the filter. Also, over time, a layer of good bacteria will grow near the surface of the filter. As disease-causing pathogens pass through, they will be eaten by the good bacteria that live in this layer, eliminating up to 90% of pathogens. The final technology harnesses the amazing power of the sun. Solar disinfection uses UV radiation from the sun to kill remaining bacteria. Water intended for drinking is placed in direct sunlight and UV radiation hits and destroys their DNA. This renders the pathogens unable to reproduce or cause harm to the human body, resulting in a much safer drink of water. At the conclusion of the presentation, members of both Sadguru and the honors trip signed an agreement to continue our relationship. It affirmed that the University of Cincinnati honors program is committed to the research and development of improving sustainable potable water systems in developing countries. As part of this commitment, a follow-up class is being held during winter quarter to use the data that we collected to research better solutions, keeping in mind the specific design constraints and opportunities unique to rural India. During our class and time in India, we gained a wealth of information about potable water and the issues surrounding it. But we also learned so much more. We experienced a country with several millennia full of rich history, in the midst of a meteoric rise towards a future as a key player in the modern world. We saw stark contrasts between tribal villages and some of the largest urban centers in existence. We were welcomed by a people with diverse cultures, religions, and traditions, held together by a strong Indian identity.